Good morning, everybody. We'll wait a few minutes for more people to waltz on in. Looks like we have 6 people so far. That's awesome. We'll just keep waiting. Hopefully we can get maybe a dozen or so people. So that would be great. We'll just hang out here for the next couple minutes. Hi, good morning. Yummy coffee. Okay. Oh, look at that. I looked down for a second and we're already almost at 20. Okay. Awesome. Let's let's get started then. We're gonna look at we're gonna sort of carry on from what we were talking about last class on Thursday. It's been a while since we've had a class because Monday was an in-service. I hope you guys had a nice little day off, extended long weekend. Anyway, we're gonna carry on looking at square roots and things like that. In particular, we're gonna look at how they can be turned into decimals, or how we can approximate them with decimals. It should be pretty fun. Before I do that, I want to talk a little bit about our final exam. Okay. Now, several students have been asking me about the final exam, which is, no surprise. It's probably on your mind. It's coming up in a couple of months, about less than 2 months, right? We got all of May and or the rest of May, so not all of May, the remainder of May, and then June. So, and that's all we have for the school year. So we're coming close to the end. As you know, the final exam is worth 30%. 30% of your grade. Okay, that's a lot. That's almost a third of your grade. That's for the whole year as well. So it's a substantial contributor to your final grade. So you may be wondering what we're going to be doing, because having a final exam when we are doing distance learning has a lot of potential to go poorly, right? So what I thought we could do is I'd like to take a survey today. So I'll mention this again at the end of class, just to remind you to fill out the exit slip. But for the exit slip today, what I'd like you to tell me is what you would like out of a final exam. So what kind of aspects of a final exam would you like? Now, just to give you an idea of what I'm talking about, Here's some ideas that I've had that we could do instead of a final exam. Can the final exam lower your grade if you get a worse grade? Absolutely it can. Yeah, it can absolutely lower your grade. It would not lower your grade any lower than what it was on March 20th or whatever that date was. So yeah, that it wouldn't go any lower than that. That said, yes, it can still lower your grade, but not lower than the March, I think it was the March 20th cutoff date. So anyway, for a final exam, I mean, one thing that we can do is we could just have a regular final exam. So that would be one, I'm just gonna write FE, final exam. So that would be like through Google Classroom, right? It would kind of just be like an assignment, right? Except it'd be an assignment with a very short due date. So like a 24-hour assignment kind of thing, or even less. I don't know, maybe a 3-hour assignment, right? Like because that's how long you would have in class. So we could talk about the particulars of that. That'd be one option, is just to do a final exam, just regular cut and dry final exam. Another option is a project. Okay. So I really like the idea of a project, because a project, it gives you an opportunity to show your understanding and show your learning without having to deal with all of the weird things that come with a final exam when I can't physically see you, right? Like if we do have a final exam, it's going to be challenging and also stressful for you. So I like the idea of a project. There's many different methods of doing a project. I could talk a lot about projects. I think that there's a lot of good ideas for projects, and I think that some projects are not good ideas. I've been teaching for a few years now, and I've seen projects kind of get out of hand a little bit. So if we did do a project, we'd have to sort of really talk about the scope of the project and talk about the content and that sort of thing. So that would be one option, is to do a project. And I guess, can you still see that? Okay, I'll do this. And then the last idea that I had is a reflection piece. And this idea was recommended to me by another teacher. So the reflection piece would look something along these lines, and we could talk a little bit about, again, we talk about the particulars if we decided to do this. So the reflection piece would be this idea where you would look at a topic that you really struggled with at some point in the year, and you described what it was about that topic that you found challenging. And when you do that, then I think two things happen. First of all, you get a better sense of where your learning occurred and where it didn't. And then also it gives you a second chance to prove yourself, right? To say, okay, you know what? Like, oh, okay, yeah, in January we were talking about, this and that, and I was really stressed out at the time. I was trying to make the basketball team, and I didn't make it, and I was really stressed out. Wasn't a good time for me. But you know what? I can figure this out, and here's that topic, and here's everything that I know about the topic, and it would give you like a second chance to learn something that maybe you struggled with earlier in the year. So these are the three things that I have sort of thought of and thought that we could possibly do, is just a regular final exam. So just like maybe a 5 or 6 page test that you have 3 or 4 hours or 24 hours, I don't know, a short amount of time to complete. That would be one option, and it would be done through Google Classroom. The other option would be a project. So again, that could look like all sorts of things. It could be something like an essay. It could be a video series. I don't think that's allowed, Alex. Probably not. So yeah, I did actually mention that. I'm just looking at the chat right now. So the final exam can lower your grade. It absolutely can lower your grade. But remember that we do have a minimum grade. The minimum grade is that you got in March 20th. So can your grade go lower from a final exam? Absolutely, but it will not go lower than what your grade was on March 20th. Anyway, so yeah, the project could look like a whole lot of things. It could be a presentation, right? Like I could give you the keys to my YouTube channel for a minute, and then you could present to the rest of the class. I don't know. There's a lot of options. You could do something in Minecraft. You could show me a cool thing that you did in Minecraft but I mean it has to be related to a math topic that we covered. But I don't know, maybe if you want to like calculate the probability of the number of diamond thing, but I don't know. You could maybe do a project in all sorts of ways. But again, we'd have to talk a lot about scope. And then finally, yeah, the reflection piece, where you can sort of give yourself a chance to sort of look back on a topic that you struggled with, if we do decide to do that one, then we'll talk about what would be the expectations there. So are we voting for one of these three? Yes, we are. We're not right this second. It's going to be part of our exit slip. So our exit slip today is going to be, I'll write this out again. So the exit slip. And yeah, like I said, I'll write out the exit slip again at the end of class so we don't forget. But the exit slip for today is to vote for what you prefer for a final exam. Okay, and I kind of presented these ideas with my grade 11 class yesterday, and several people voted that they would like a choice, I think a lot of people, I mean, let me just tell you a little bit about what I would choose if I were you. I would want to do the final exam, the regular final exam, and I'm not saying that because I'm some kind of weirdo, but you have to put things in perspective. The final exam is, what's on it. It's going to be the topics that we've been covering all year. No surprises on what's going to be on the exam. The exam is going to take no longer than 24 hours. It'll be one day of really hard work, just really, really hard work. You're going to push yourself, and then it's done, right? Now, like I said, I've been a teacher for a few years, and I've seen how projects can go. The amount of time that a project takes it always takes longer than you think, right? If you give a class 2 weeks to do a project, I can guarantee you that about 30% of the class at the end of the 2 weeks isn't going to be finished, and they're going to need some extra time. So projects are super fun and they're awesome, but you also have to put into perspective like the amount of work that it's going to take, right? And then same with the reflection piece, right? That's like a week or 2 weeks worth of work, right? I would expect basically like almost like an essay style, kind of like writing about your learning process, and then I would also want you to be able to demonstrate that now you can do it. So there still would be some math. So you would actually have some math in there, and you'd give me some examples. So all of these are a lot of work. The final exam is like one day, right? But not everyone wants the final exam because that's frankly really stressful, and this is a stressful time, so maybe you don't want to do that. So some people in grade 11 were mentioning that they think that it would be good to have a choice, and I'm open to that. So if you would like to have a choice, that's fine. Also, if you can think of something else that I didn't list, let me know, okay? Oh yeah, you finish everything the night before, and it always works. Yeah, like a big project, a final project for a full year class, just start at 11:30 when it's due at midnight. Yeah, no, I'm being sarcastic. No, don't do that. If we did do a project, we would probably spend the last week or 2 weeks kind of talking about the project, and I would ask for updates. I wouldn't be okay letting people start the project the day before that it's due. That would it would be unfair to you, right? I mean, as a teacher, part of my responsibility is just to make sure that you're doing what you're supposed to. So if I were to just let you start it the night before, I wouldn't be doing my job. So if we did do a project, then I would need some updates. We would probably spend a week to 2 weeks on it. I'm hoping it would be more like 1 week instead of 2 weeks, because 2 weeks is a long time, right? I think we have something like 7 weeks before the end of class, so 2 weeks that's a lot of time. So yeah, let me know what you think in the exit slip today. Don't fill out the exit slip quite yet. We still have a lot of material to cover today. But yeah, what I thought we'd do is talk a little bit about our final exam. So that's the final exam. So you got a few different options there. You can choose one of these. I mean, if the whole class just wants a regular final exam, then I'll do a regular final exam. But if a lot of people want different things, then I might give you the option to do any of these. And if everyone just wants to do the reflection, then we'll just do the reflection, right? So I want to hear from you. Also, if you have your own idea that I didn't list, then let me know, and I'll consider that for sure. But I think most ideas that are sort of out of the box, like thinking outside the box kind of ideas, would probably fit into the project category anyways. So, I mean, you could even think of the reflection piece as a project, right? So, anyway, let's talk a little bit about square roots now. Okay, so what we're going to be doing today, unless there's anything else that anyone wants to add to this conversation before I move forward, but it looks like the chat is pretty quiet right now. Okay, so what we're going to be doing today is we're going to be approximating. Square roots We're going to be approximating square roots with, what am I trying to say here? We are going to be approximating square roots with decimals. Okay, that's the name of the game today. Okay, so there's several ways of doing this. I mean, obviously the most straightforward way is to use a calculator. But I mean, obviously that's not what we're going to be learning about today. Okay, so what we're going to do is just start off with a few examples. So note, if a decimal, or if oh yeah, you know what? If they're doing a regular exam, will you put together an exam review? Absolutely, we'd be doing an exam review. If we were to do a final exam, then yes, we would absolutely do an exam review. Good question. Thank you, Mr. Schiffman. I thought there was something else. Oh yeah, the assignment. I wanted to set some time aside for the assignment, so I guess I'll do that at the end of class. So maybe the last 5 minutes I'll give you an opportunity to ask some questions about the assignment. Would we have to do the review? Well, if you want to do well on the final exam, then yes. But would it be worth marks? Probably not. Okay, so if a... Yes, where was I going? So if a number is a perfect square, then the square root of it is an integer. So for example, you know, if I were to take the square root of 100, 100 is a perfect square, and so that means that the square root of 100 is equal to 10. Okay, so that's pretty straightforward, and I think that we're already aware of that. Similarly, if a number is the ratio of two perfect squares, then its square root is rational. Okay, So what do I mean by that? Well, if I were to have something like the square root of like 16 over 25, well, that would be, well, let's see here. That would be the square root of 16 over the square root of 25. Square roots work like that. If I have a quotient or a product under a square root symbol, then I can split it up into that quotient or product. And this is equal to, well, 4 over 5. Similarly, and this, what I'm about to do right now is relevant to your assignment, so I would pay very close attention here. So, for example, let's say we wanted to calculate the square root of 0.25. Okay, that's a quarter, right? Square root of a quarter. So keep in mind that this is equal to the square root of 25 over 100, right? That's what 0.25 is. And look at those. Those are both perfect squares. So this is going to be the square root of 25 over the square root of 100, which is equal to 5 over 10, or in other words, 1/2. Okay. And let's just do a quick little sanity check here. So the square root of of 0.25, that's the same thing as the square root of a quarter, right? Now, is it true that 0.5 squared is equal to 0.25? Question mark? Well, I sure hope so. I sure hope so. Well, I mean, let's think about it. 1/2 times 1/2 is a quarter. Yeah, there you go. So it actually does work out. Okay. So these are the cases that don't require too much like involvement on our part. So what I mean by that is, like, if I were to ask you to take the square root of a whole number, or sorry, a perfect square, you just calculate it, right? And last class on Thursday, we looked at a lot of different methods for solving square roots of perfect squares. Remember that all of the examples that I gave you, I gave you a perfect square. So we would find all the factors and realize that all the prime factors were squares, so we would just take the square root of those. So that's what we did on Thursday. What I want to do now is I want to talk about how to look at, so let me just explain this clearly. So what about the cases? What about cases where we want the square root of a number that is two things: not a perfect square. So it's not a perfect square. So we can't just like take the straight out square root of it. So we can't just find we can't find the prime factors. We can't find the prime power decomposition and just knock off all the exponents of 2 from it. So it's not a perfect square, and it's also not the ratio of a perfect square. Okay, so what about those cases? Well, let's talk about that. Okay, so for example, what about the square root of 5, right? So I've got my handy dandy pocket calculator here, and I will punch in the square root of 5. Oops, square root of 5. And this gives me 2.236067977 ... This is irrational. Okay? Oops. So, just as a fact, I'll give you a quick fact here. If a number is not a perfect square, if it's not a perfect square and not the ratio of perfect squares, then its square root is irrational. Okay, so this is why we were learning about irrational numbers, is because they come up. So, like, the problem here is, the reason why we're studying this and the reason why this is interesting is because we're faced with a problem. How do we write irrational numbers? Okay, so remember, an irrational number has an infinite number of digits. It's non-terminating. So those decimals, what's the ratio of a perfect square? So ratio of perfect squares. Give me two perfect squares. Like, how about 64 and 25? That's a ratio of perfect squares. Ratio of perfect squares. So this is what a ratio of perfect squares is. Like a fraction where the numerator and the denominator are both perfect squares. So if a number is not a perfect square and is not the ratio of perfect squares, then its square root is irrational. And there's some very slight, I should be a little bit more careful here. There are a few weird cases where that's not true. What I should really say is if a rational number is not a perfect square and not the ratio of perfect squares, then its square root is irrational. Because there's some really weird irrational numbers that you can take the square root of and you get a rational number back. But that's neither here nor there. In our case, all the numbers that we're going to be looking at, if it's not a perfect square and it's not the ratio of perfect squares, then the square root is irrational. So that's what we're going to be looking at. So the issue is that we can't actually write these numbers down. So we can't, right? There's an infinite number of digits and they don't repeat, right? So, I mean, just because you have an infinite number of decimals doesn't mean you necessarily can't write it down. Like, for example, 1/3 is 0.3333333, blah, 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 keeps on going on and on and on. We write this as 0.3 repeating, right? So just because you have an infinite number of digits doesn't mean that you can't write it down. The problem is something like pi, which is 3.14159, blah, 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 and you can't write those digits down. So we typically just write it as the symbol, okay? What we're going to be doing today, in today's class, is we're going to be learning how to approximate. How to approximate square roots. Okay, so I've shown you how to calculate the square root of big numbers using prime power decomposition, and if it's a fraction, then you just split the fraction up into two square roots and that kind of thing. What I want to do today is I want to look at how to approximate square roots that aren't perfect squares. So I think that the best way we could do this is just with an example. So let's try square root of 7. So I'm going to say approximate square root of 7. Okay? I'm going to approximate the square root of 7. Okay. So here's what we're going to do. So the step one, list some perfect squares that are close to 7. Okay, yeah, thanks. Thanks for the 2.6. That's great. But what I'd like us to do is to look at methods of doing this without a calculator. So as far as I understand, I don't think you guys have done this already. If you have done this in the first semester, just let me know and I'll move on to something else. But as far as I know, I don't think you've done this yet. Anyway, so we're going to take a look at some perfect squares, that are close to 7. So let's say, well, I know that 4 is a perfect square, right? 2 squared is 4. 3 is a perfect square. Sorry, not 3. 9 is a perfect square because 3 squared is 9. Okay, yeah, that's what I thought. You might notice that 7 is right in between these. So these two numbers here, 4 and 9, these are consecutive perfect squares. Okay, so consecutive means one right after another. There is no perfect square that is between 4 and 9. Okay, and that's because 4 is 2 squared and 9 is 3 squared, and 2 and 3 are consecutive integers, right? They come right after another. So that means that since 4 is less than 7, which is less than 9, we get the square root of 4 is less than the square root of 7, which is less than the square root of 9. And well, we know what the square root of 4 is. Oh, I don't know if you can see that. Actually, my head's probably in the way. The square root of 4, we know what that is, 2. So 2 is less than the square root of 7, which is less than the square root of 9, which is 3. Come on, let me write that nicely. 3. Okay, so 2 is less than 7, which is less than 3. So the square root of 7 lies somewhere between 2 and 3. Yeah, I think some of you may have done this last year. It is I think technically a grade 8 topic to approximate some of these, but we're still gonna cover it. We're gonna cover it in a little more detail than you may have already. Okay. Let's see here. So 7, the square root of 7 is equal to 2 point something. And our next task is to figure out what that next decimal place is. Okay? Like 2 point something. Right? We know that it's bigger than 2 but less than 3. So it's going to be 2 point something. Okay? So here's how we can approximate this. Okay? So if we were to write a number line here, here's where 7 is, and 4 is, I guess, 6, 5, 4 over here. So 4 is over here. And then 9, 7, 8, 9 is over here. Okay? So here's 9. So when we take the square root of these ratios, they don't remain exactly the same, but they remain fairly close to being the same. So what I mean by that is we can approximate what this next decimal place is based on the ratio of this to this. Okay? So let's expand on that idea. So 4 is 3 units away from 7, and 9 is 2 units away from 7. So between 4 and 9, we have a total of 5 units. Okay, there's a total of 5 units between the two of them. Okay, so what we're gonna do is we're gonna say that this next number, I'm gonna call this this D for digit. So our next digit is going to be 3 out of 5 units away. Okay, so that's how we actually handle this. It's 3, like this 3 out of the entire 5 units between them. So we can kind of think of this as being one extra square root, right? So what we're doing is we're saying how much of this one. So we think of this as a whole. Okay, we think of this as our whole. So between 4 and 7, that would bring our square root up by 1. But we're not going all the way there. We're going 3/5 of the way, because this whole is split up into fifths, and we're going 3/5 of the way. So 3 over 5 is equal to 0.6. So our next digit is 6. So we can think of this as being 2.6. Okay? So the square root of 7 is very close, and I shouldn't actually say it's equal. It's not actually equal. What we're going to say is if you round it, then we will put a little dot on top of the equal sign. If we round it to the nearest tenth, it's going to be close to 2.6. So that's how we approximate it. And if we punch this into a calculator, we would have, well, the square root of 7 is 2.645. So we were pretty close. Okay, so let's do a couple more examples. Let's try. Let's try the square root of 11. Okay, let's try. Oops. Let's do square root of 11. Okay, so I'm going to get you to do that one. So I'll write approximate square root of 11. Okay, so I want you to approximate the square root of 11. And I'll give you a couple of minutes to do that. Let's say 1 minute, because we're going to have to wrap things up pretty soon. Okay, there's your minute. Yeah, I wouldn't be surprised if you did see this a little bit in grade 8. It is a grade 8 topic, but I think it's important that we do it now. Okay, so we're going to approximate the square root of 11. So 11 is somewhere between 9 and 16, right? And both of these are perfect squares. So the square root of here, let's say this. So yeah, okay, so 3 squared is less than 11, which is less than 4 squared. So that means that 3 is less than the square root of 11, which is less than 4. So 11 is somewhere between, the square root of 11 is somewhere between 3 and 4. So it's going to be 3 point something. We need to figure out what that something is. Well, 11 minus 9 is equal to 2, and 16 minus 11 is equal to 5. So 11 is 2 away from 9, and it is 5 away from 11, or sorry, 5 away from 16. So that means that we're a little bit closer to 9 than, or sorry, we're a little bit closer to 9 than we are to 16. So what we can do is we can say that our next digit, oops, not 9, is 2, I keep writing 9, 2 over 2 plus 5. So 2 over 7, which is, if I round this is going to be 0.3-ish. So our number is 3. So this is close to 3.3. So let's just double check. 3.3 squared, 3.3 times 3.3 equals, yeah, this is, so if I do 3.3 squared, that's equal to 10.89, very close to 11, right? And if we actually do the square root of 11, I should say, by the way, 11 is equal to, or when you round, that's equal to 3.3. So let's actually take the square root of 11. So the square root of 11 is equal to 3.31. Yeah, so there it is, 3.31. You can see right there. So yeah, we're done. Okay, so I want to give you just a few minutes to ask some questions about, yeah, you guys got it. I want you to ask some questions about the assignment if you have any. It is due today. I know a couple of students have asked for an extension, and I've granted that. So I will be putting the solutions up on Friday. So I won't put up the solutions today. But yeah, if you have any questions, you can ask them now. It doesn't really seem like you do have any questions, so we can go straight to the exit slip then. I'll just bring up the exit slip again. Here we go. Okay, and if you do have a question, just say so in the chat. Okay, so for the exit slip today, let me just reiterate myself just in case you weren't here when I was mentioning it the first time. So for the exit slip today, I want you to think about what you would prefer for a final exam. Would you like just a regular final exam? Would you like a project, or would you like a kind of a reflection piece? So let me know which one you would prefer. It looks like someone is asking about the last question. Okay, so I don't have the whole assignment memorized, so I'm just going to bring up that question. Where did I put the assignment? I'll just check Google Classroom. Grade 9. Assignment 2, digital assignment 2, and how do I look at the assignment now? Instructions. Digital assignment 2. Yeah. Oh yeah, this is a good one. Haha. How does it help you calculate? Okay. Good question. Okay, so let me give you two numbers here. Let's do 6 and 15. Okay, so 6 times 15. That's easy to calculate, right? 6 times 15. 6 times 15 is equal to 90, right? Yeah, so 6 times 15 is equal to 90. Okay, what's the GCF? Just tell me quick in the chat. What's the GCF? Actually, you know what? There's a lag. So if we did this, we would have like a 30-second delay between what I say and what you see, because you see it about 30 seconds after I say it. So the GCF is 3. Okay, I just know that. And then the LCM. Now that I find that the GCF is easy to calculate. The GCF is easy to calculate because I just look at the factors of the numbers and I say, okay, yeah, no, those are easy to calculate. Also, multiplying numbers, also very easy to do. We've been doing that since like grade 3, right? We can multiply numbers. GCF's also fairly straightforward to calculate. LCMs, that's where it's hard to calculate. And we need to use LCMs all the time, right? LCMs come up when we're adding fractions and all that fun stuff. So I find LCMs kind of tricky to calculate. I don't know about you. But let's see if we can figure out what the LCM is. So we would need 6 times 5, which is 30. Okay, so the LCM, oops, I don't know what happened to my color there. LCM is 30. The GCF times the LCM That's equal to 3 times 30. Hey, look at that. It's also equal to 90. Right? Yeah, okay, so that's good. So let's just say that the product of two numbers is easy to calculate. The GCF of two numbers also easy to calculate, right? The LCM is hard. So assume that. Assume those three things, that it's easy to calculate the product of two numbers. Assume that it's easy to calculate the GCF. By the way, my YouTube thing is like I'm getting a loading bar. Let me know if my stream is kind of breaking up, but I think it's probably fine. So yeah, assume that calculating the product of two numbers is easy. Assume that calculating the GCF of two numbers is easy, and also assume that calculating the LCM is hard. Yes. How about 11 o'clock would be fine. Okay, so yeah, that's what I'd like you to assume, is that let's just say that calculating the LCM is hard. So how could you use the product and the GCF to calculate the LCM? Okay. All right, so that concludes our lesson today. I will talk to you guys on Friday. And yeah, good luck with your assignment. It is due today at the end of the day. So yeah, good luck with that, and talk to you guys on Friday. Bye-bye.